A cache is a truly fast kind of memory. A PC has various types of memory inside it. There is a primary storage, like an external disk, which stores the majority of the information, the operating system and all the programs. Next up, we have the random access memory, usually known as the RAM. This is much faster than the primary storing. Lastly, the CPU has even faster memory units within itself, which we know as the cache. The memory in a computer has a hierarchy, created upon the speed, besides cache positions at the topmost of the hierarchy, being the fastest. It is to the neighboring to anywhere the central processing occurs, being a portion of the CPU. Cache is a static, as compared to the computer RAM, which is a dynamic RAM, DRAM. Static RAM is unique that can hold data without needing to be constantly refreshed, unlike DRAM, which makes SRAM perfect to be used for cache. A program is designed as a set of instructions, to be run through the central processing unit. Once you run a program, these instructions have to make their way from the main storage to the CPU. This is somewhere the memory hierarchy comes into play. The computer chip needs access to superfast memory. This is where the cache comes in. The memory manager does the job of taking the information from RAM and sending it to the cache. Depending upon which microprocessor is in your system, this controller can either be on the North Bridge chipset on the motherboard or else inside the CPU itself. CPUs these days are capable of carrying out a gigantic number of instructions per second. The cache then carries out the back besides forth of data inside the CPU. The hierarchy of memory occurs within the cache, as well. CPU cache is separated into three main levels, L1, L2, and L3. The hierarchy at this time is once more according to the speed, then thus, the size of the cache. Multi-core CPUs will usually have a discrete L1 cache for individually core. Level 1 cache is the fastest memory that is almost in a computer system. In terms of priority of access, L1 cache has the information the CPU is maximum likely to need although finishing a certain task. The L1 cache classically drives up to 256 kilobytes. Nevertheless, some truly powerful CPUs are nowadays taking it close to 1 megabyte. Some server chipsets nowadays have somewhere among 1 to 2 megabytes of L1 cache. L2, Level 2, cache is slower than L1 cache, but larger in size. Its size characteristically varies among 256 kilobytes toward 8 megabytes, even though the newer, powerful CPUs tend to go past that. L2 cache holds information that is likely to be accessed by the CPU next. In most recent CPUs, the L1 and L2 caches are present on the CPU cores themselves, with each core receiving its particular cache. L3, Level 3, cache is the largest cache memory unit, but also the slowest one. It can range among 4 megabytes to upwards of 50 megabytes. Modern CPUs have dedicated space on the CPU die for the L3 cache, and it takes up a huge mass of the space.